Welcome back. Problem 4-14. This problem is taken from chapter number 4, that is Axial Load, and the book name is Mechanics of Material by R.C. Hibbeler. So statement is the post is made of Douglas fir and has a diameter of 60 millimeter if it is subjected to load of 20 kilonewton and the soil provides frictional resistance that is uniformly distributed along its side. W is 4 kilonewton per meter. Determine the force F at its bottom needed for equilibrium. Also, what is the displacement of the top of the post with respect to its bottom? Neglect the weight of the post. So you can see this is the post that is made up of wood, and this is Douglas fir, and that is subjected to 20 kilonewton load, and this soil provides fractional load, that is W, and that W is 4 kilonewton per meter uniformly distributed load. So you have to find this force F for the equilibrium of this post, and then you have to determine the displacement of this point A with respect to B. Due to this load, it will compress, causing this, there will be a deflection. So you have to find this displacement of A with respect to B. So let's start with the solution. So first we will take this whole for entire post as free body diagram in order. For entire post as FBD. FBD means free body diagram. Clear? So we will take this entire post. Let this is the post. Clear? And we have a 20 kilonewton load at the top, and at bottom we need to find this force F. Clear? For equilibrium purpose. And you can see this uniformly distributed load along the side, and when it is converted into point load, so W into 2, so W is given as 4 kilonewton, so 4 into 2 will be 4 multiplied by 2 is 8 kilonewton, and that will act at the middle of this post. So this force will be this one. Now we'll apply equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see one force which is this upward, the second force is this force which is upward, and third force, this is 20 kilonewton, that is downward. Their sum must be equal to 0. So minus 20 kilonewton plus 8 kilonewton plus this force is equal to 0. So from here you will get F minus 12 is equal to 0. So F will be equal to 12 kilonewton. So in order to keep this post in equilibrium, your reaction force at this bottom must be equal to 12 kilonewton. Now this is the answer of our first part. Now we'll move towards second part, and in second part we have been asked to find the displacement of point A with respect to B from top to bottom, or displacement of top of the post with respect to its bottom. So we know that this displacement of A with respect to B will be equal to load, which is equal to P into length divided by A into E. Now you can see that we have a uniformly distributed load acting along the side by the frictional resistance of this soil. So at every length of this post, this force will change. So this force, this W is a function of this Y. So what we will do is that we will take the post, we will cut this post at a distance of Y and draw the free body diagram. So from free body diagram, let this is the post that we have taken. Clear? This is 20 kilonewton. Clear? And this distance where we have cut it is taken as Y. Clear? So according to this distributed load, when converted into point load, so W into this Y, and it will act at the middle. So I will represent it. This force will be equal to W is 4 and Y is this distance. So it will be 4Y. And there, when you cut it, you will be having a reaction force which is Fy. That is a function that change with respect to y. So we can find this Fy by using equation of equilibrium, and that equation of equilibrium is sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see 20 is downward, Fy is downward, and 4y is upward. So I will write minus 20 plus 4y minus Fy is equal to 0. So you can say that Fy is equal to 4y minus 20. Now if y is equal to 0, so we get Fy is equal to minus 20 kilonewton. So you can see that this is correct, because here this will be minus 20, that is downward. So at this surface the force acting is compressive force. Clear? Now what we will do is that we have to find this displacement of point A with respect to B, and that will be equal to, for entire length of 0 to 2 meter. Clear? That can be written as Fy, this force, into small length dy Ay into E. Since diameter of this post is given as 60 millimeters, so diameter is same, so area will be remain throughout. So we will take 1 over A into E, because these are constant. So we will left with 0 to 2 meter, and that is Fy into dy. Okay. Now what we will do is that we will integrate it. So displacement of point A with respect to point B will be equal to 1 over A into E, and Fy is integral of 0 to 2 meter, and this Fy is 4y minus 20 into dy. So you will get displacement of point A with respect to B is 1 over AE, and we will left with the integral of 4y will be equal to 4y square over 2, and its limit will be 0 to 2 minus 20 into y, and its limit will be from 0 to 2. Okay. So if you further simplify, displacement of point A with respect to B will be equal to 1 over A into E, and you will get, if you put y as 2, so 4 into 2 square divided by 2 minus 4 into 0 square divided by 2. Similarly, if you take whole bracket minus 20 into 2, clear, minus 20 into 0. So you will get, this will be equal to 1 over AE, and 2 1 2 2s are 4 4, and 2 square is 4 4 2s are 8. So 8 minus this will be 0 minus 40 minus 0. So you will get 8 minus 40 divided by AE. This will be displacement of point A with respect to B. So we will get minus 32 divided by A into E. Now you can see the unit of force is kilonewton. So this displacement of point A with respect to B is minus 32 kilonewton, and divide by this A into E. Okay. Kilonewton into meter, because this is Fy into this distance. Okay. So minus 32, we will remove this kilo, so 10 raised to power 3 Newton into meter. Area of this circular shape is pi by 4 d square, and d is 0.06 square. Let me check it. You can see 0.06 meter. And what about E? So for E, we have been given that this is Doppler. So we have to go to the end of the book, and from the property table at the end you can see there is average mechanical property, second last one. So when you click it, so you will get this. You have to search it. Now you can see here we have wood. So wood is Douglas fir, and its E is 13.1 gigapascal. So 13.1 into 10 raised to power 9. So I will write 13.1 into 10 raised to power 9. Okay, so when you solve this, you will get this displacement of point A with respect to B will come out to be minus 0.8639 meter into 39 into 10 raised to power minus 3 meter, or you can say displacement of point A with respect to B is minus 0.8639 millimeter. Now this minus sign shows that point A minus, let me write it, minus sign shows that point A moves towards B. And that was all about this problem 6-14. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching. Welcome back. In this video, we are going to solve problem 4-34 that is taken from chapter number 4, Axial Load, and book name is Mechanics of Material by R.C. Hibbeler. So statement is if column AB is made from high strength precast concrete and reinforced with 4 3 by 4 inch diameter A36 steel rods, determine the average normal stress developed in the concrete and in each rod. Set P is equal to 75 kips. So you can see this is a column AB that is composed of the cross section of the column is given as here, that is 9 inch by 9 inch, and there are 4 steel rods in that. Clear? So you have to find the average stress in this concrete and as well as average normal stress in this steel rod. The load P is given as 75 kilonewton. So let's start with the solution. So if I cut this concrete rod over any length, clear, and draw the free body diagram, so it will be like this. Let me draw the free body diagram. This is the free body diagram. Clear? The load over here is P, which is 75, and that is 75 kip. Clear? And same here we have 75 kip load. Now you can see in reaction you will be having a reaction force, and you can see that this load which is 75 and 75 that will be taken by this column AB, and the column AB consists of concrete as well as A36 steel rod. Clear? So the load will be taken by the concrete and steel rod. So I will write first P concrete and this P steel. So total load will be equal to P concrete plus P steel. So we'll apply equation of equilibrium for finding this P concrete and P steel. So this is the equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. And you can see that since we have 4 concrete steels, clear, sorry, 4 concrete, 4 A36 steel rods, so we have this 4 times P steel. Clear? Okay, so sum of all forces along y direction must be equal to 0. So minus 75 plus P concrete plus 4 times steel will be equal to 0. So I will write it minus 75 plus P concrete. P concrete means load taken by the concrete plus 4 times load taken by the steel is equal to 0. So minus 2 times 75 plus P concrete plus 4 times P steel is equal to 0. Let this is your equation number 1. We cannot find because there are two unknowns. Now what we will do is that you can see due to this load, this load, the compression or change in length in this column AB will be the same in concrete as well as in this 4 steel rods. So I will write compatibility equation. So what does compatibility equation tell us? Compatibility equation. So I will write since the steel bar and concrete are firmly bonded, therefore the deformation will be same. The deformation will be same. So we will write deformation of concrete will be equal to deformation in steel rod. So we know deformation is equal to P into L divided by AE. So I will write P concrete into length of this concrete divided by area of concrete into modulus of elasticity of concrete, and that will be again equal to P of steel into length of steel clear divided by area of steel into E of steel. Now P of concrete is not known, so I will write P of concrete. This column length is 10 feet, so I will write 10 feet and we will convert into inch. 1 inch is 1 feet is equal to 12 inch, so 10 into 12 will convert it into 120 inch divided by area of the concrete into E of concrete. Similarly, P of steel into length of steel is also 10 feet. So 10 into 12 will be 120 inch divided by area of steel into modulus of elasticity of steel. Now you can see we have been given the cross-sectional area of this plate, that is 9 by 9, and there are 4 steel rods. So this is 9 inch and this distance is also 9 inch. Clear? So this area, which is cross hash area, if you remove the 4 steel, so this is the area of the concrete. Area of concrete, and area of concrete can be obtained by using area of concrete is equal to this total area, which is 9 by 9. So 9 multiplied by 9 minus the area of 4 this steel rod. So 4 times area of this rod is pi by 4 into d square, and diameter of each rod is 3 by 4. So 3 by 4 square. So this is the area of concrete, and area of steel is equal to steel rod is equal to pi by 4 d square. So pi by 4, 3 by 4 whole square. Now what about E of concrete and E of steel? So you can see we have the material, so you will go to the end of the book, and then in book you will go to the property tables at the end, average mechanical properties. So this is for SI unit. We will go to US customary. So you can see A36 is this one, which is 29 into 10 to the power 3 KSI, and high strength concrete. So this is concrete and its high strength is its modulus of elasticity is 4.220 into 10 to the power 3 KSI. You can see over here, this is 10 raised to power 3 KSI. So note down this value. I will write E of concrete is 4.20 into 10 raised to power 3 KSI, and the area E of steel was 29 into 10 raised to power 3 ksi. Now you have all the values, you can just put it. So we will get P of concrete into 120 divided by area of concrete is 9 multiplied by 9 minus 4 times pi by 4 into 3 by 4 whole square. This is area of concrete multiplied by E. So E is 4.20 into 10 raised to power 3. And that will be equal to P of steel multiplied by 120 divided by area of steel is pi by 4 d square, and d is 3 by 4 into E, which is 29 into 10 raised to power 3. So when you calculate it, you will get at the end, you will get P of concrete will be equal to 25.974 P of steel. This is your equation number 2. Now what we will do is that put equation 2 in equation number 1. Clear? Equation number 1 is this one. This one is the equation number 1. So when you will put it, you will get P of steel will come out to be 5.0043 kip. Okay, so when you get this value, you put P steel in equation number 2. So you will get P of concrete, which is 129.98 kips. So it means that major load is taken by or the load that is taken by concrete is this one, and the load that is taken by the steel is 53.04 kip 004 kips. Now what we have been asked to find the average normal stress in concrete, which is equal to load of the concrete divided by load taken by the concrete divided by area of concrete. So 129.98 kip is the load, and area is 9 multiplied by 9 minus 4 times pi by 4 into 3 by 4 square. So when you solve this, you will get it 1.64 ksi. So this is the average normal stress that is taken by concrete is 1.64 ksi. And the average normal stress that is taken by steel is equal to P of steel divided by area of steel, and P of steel is 5.0043 kip divided by area, which is equal to pi by 4. This is the average normal stress taken by each steel rod. So 3 by 4 whole square, and that is equal to 11.3 ksi. So average normal stress in steel is equal to 11.3 ksi. And that is the answer of our this question. And this was all about this problem 4-34. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching. Welcome back. In this video, we are going to solve problem 4-35 that is taken from chapter number 4, Axial Load, and book name is Mechanics of Material by R.C. Hibbeler. So statement is, if column AB is made of from high steel precast concrete and reinforced with 4 3 by 4 inch diameter A36 steel rod, determine the maximum allowable floor loading P, the allowable normal stress for high strength concrete and steel are, this is for concrete and this is allowable stress for steel rods respectively. So you can see this is column AB that is made up of concrete portion as well as 4 steel rods that are binded in this concrete rod, and you have to find this floor loading P for the allowable stress in concrete and steel. So let's start with the solution. So if you cut this column at any length and draw the free body diagram, so let me draw the first free body diagram. So let this is let this is the column, this is the load P that is acting on this floor of the column or floor. So you can see when you cut it over here, so there will be reaction force, and this reaction force will be the load taken on concrete, which is P concrete, and the load taken by this steel rod, so P steel. And this there are 4P steel, so there are 4 rods, so it will be 4P. So reaction force will be P concrete and 4 times P of steel, and total reaction will be equal to P concrete plus 4 times P steel. So we'll find this P by using equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see these two P's are downward, so minus 2P plus 4 plus P of concrete, which is upward, and plus 4 times P of steel, that is equal to 0. So we will have this is equation number 1. Now due to this load, clear, there will be a deformation in this column. So this column is made up of concrete and as well as this steel rods, clear. So deformation in both materials will be same. So that is what we call compatibility equation. So we will write compatibility equation, compatibility equation. So I will write, since the steel bars and concrete are firmly bonded, therefore their deformation will be same or must be same. Now it means that deformation in concrete will be equal to deformation in steel, and we know that deformation in concrete is equal to P concrete into length of concrete divided by area of concrete into modulus of elasticity of this concrete, and deformation in steel is equal to P steel into length of steel rod divided by area of steel rod, clear, into E of steel. So first we will find this area of steel rod. So you can see you have, this is the plate for example, and there are 4 steel rods, not plate, this is a cross section of concrete. So this is 9-inch and this is also 9-inch. You can see it over here, 9-inch by 9-inch. So what will be the area of concrete? So area of concrete will be this shaded portion. If you remove these 4 steels, so this will be the area of concrete, and this is AC. Now this AC will be equal to, if you take the whole cross section which is 9 by 9 and you subtract these 4 steels, so 4 area of steel is pi by 4 into d square, so d is 3 by 4 whole square. And what is the area of steel rod? So pi by 4 d square, so it will be pi by 4 3 by 4 whole square. And we will also need E of steel as well E of concrete. So for what we will go to the end of the book. So for finding E of steel and E of concrete, we will go to the end of the book, and at the end of book you will have average mechanical property of typical material in US customary. So for concrete, you can see high steel is 4.20 into 10 raised to power 3 ksi, and for A36 steel it is 29 into 10 raised to power 3 ksi. So note down this value. E of steel is 29 into 10 raised to power 3 KSI, and E of concrete is 4.20 into 10 raised to power 3 KSI. Now you have all the value. You do not know P concrete, so P concrete will be there. Into length of this concrete column is 10 feet. So 10 into 12 will be 120 inch. We are converting it into inch. Divided by area of concrete, which is 9 by 9 minus 4 times pi by 4 into d square, so which is 3 by 4 whole square, and E of concrete is 4.20 into 10 raised to power 3, which is equal to P of steel. So P of steel into length of steel is 10 feet, so 10 into 12 divided by area of steel, which is pi by 4 d square, and d is 3 by 4 whole square, into E of steel 29 into 10 raised to power 3 ksi. So when you solve this at the end, you will get this P of concrete will be equal to 25.74974 P of steel. That this is equation number 2. Now what we will do is that put equation 2 in equation number 1. This is the equation number 1. Clear? So what we will get is that you will get P of steel will be equal to 0.06672 times P. Clear? Now you have this P of steel. Put P of steel in equation number 2. So you will get P of concrete will be equal to 1.7331 times P. So you have P of concrete and P of steel in term of P. Now what we will do is that we have been given allowable normal stress. So allowable normal stress. So allowable normal stress for concrete will be equal to P of concrete divided by area of concrete. Clear? So from here we know that allowable stress for concrete is 2.5 ksi. Let me show you 2.5 ksi. So 2.5 ksi will be equal to P of concrete is 1.7331 times P, and area of concrete is 9 multiplied by 9 minus 4 times pi by 4 into 3 by 4 whole square. So when you solve this, you will get this P will be equal to 114.29 kips. Clear? So this is the load that is calculated based on allowable normal stress for concrete. Now we will calculate the P load for allowable stress of steel, which is equal to P of steel divided by area of steel. So P of steel is 0.06672 times P divided by area of steel, which is pi by 4 into 3 by 4 whole square. So allowable normal stress for steel is 24 ksi. So I will write 24 is equal to 0.06672 times P divided by this area, which is pi by 4 into 3 by 4 whole square. So from here when you calculate it, you will get this P, which comes out to be 158.91 kips. Now you have two values. This value is based on the allowable normal stress for steel, and this is for allowable normal stress for concrete. So we will choose smallest one So P is equal to 114.29 kips. Why we have chosen this smallest one? Because you can see that if you put this value in this, it will satisfy, and your stress will be less than the allowable normal stress in steel. But if you put it in this, so it will exceed the allowable stress in the concrete. That's why we choose this. P is equal to 114.29 kips. And that was all about this problem 4-35. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching. Welcome back. In this video, we are going to solve problem 4-38 that is taken from chapter number 4, Axial Load, and the book name is Mechanics of Material by R.C. Hibbeler. So statement is the load of 2800 pound is to be supported by two essentially vertical A36 steel wire if originally wire AB is 60-inch long and wire AC is 40-inch long. Determine the force developed in each wire after the load is suspended. Each wire has a cross-sectional area of 0.02 inch. So you can see this is the load, that is 2800 pound acting downward. This is let W, and this is wire AB, and this is wire AC. So originally their length are given and cross-sectional area is given. So you have to find the load in this wire BC, AC, and AB and AC. So let's start with the given data. So first we will write given data. We have been given that the load which is 2800. So let this load is equal to W is equal to 2800 pounds and 2 A36 steel wire. Clear? And the length of wire AB is given as 60-inch, while the length of this AC is given as 40-inch long. That is before the load is applied. Original length is this one. Okay. Area of both this AB is equal to area of AC, which is given as 0.02 square inch. So what we have to find is that to find determine the force in each wire. So basically we are going to find out the force in A, B, and the force in AC. So we'll start with the solution. So if you look at this diagram, so let's say this is your point A, clear? So you will be having a wire AC. So the force developed in wire AC is TAC, clear? And force developed in wire AB is TAB. And the load that is acting downward, this W is equal to 2800 pounds. So by using equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see this W is acting downward, clear? So it will be negative, and these two forces are upward, so it will be positive, and their sum must be equal to 0. So I will write TAB plus TAC minus 2800 is equal to 0. Let this is your equation number 1. Now you can see due to this load W acting downward, so there will be deformation or elongation in wire AB as well as elongation in wire AC. So both are A36 steel wire. So I will write due to load of 2800 deformation in each wire will be same because they are of A36. So what we will write is that deformation which is equal to delta. So delta AB will be equal to delta AC. Since we know that delta is equal to load or force into length divided by A into E. So I will write it delta AB will be equal to TAB into length of AB divided by area of AB into E. E will be same for both. And same is for TAC into length AC divided by area AC into E. So you can just put the value. TAB is not known. So I will write TAB, length of AB is given as 60. So it will be multiplied by 60 divided by area, which is given as 0.02 inch for both. So 0.02 multiplied by E. And that is equal to TAC, which is not known. Length is given as 40 clear inch. You can see divided by area is 0.02 multiplied by E. So we do not know E. So for A36 steel wire, what you will do is that you will go to the end of the book and from the property table at the end, average mechanical properties, and that will be in US customary. So you will check A36. So you can see this is A36 and value is 29 into 10 raised to power 3 KSI. So I will note down it. E is for A36 steel. E is 29 into 10 raised to power 3 KSI. So put the value, or if you do not put, so it will be cancelled from here, clear. And at the end you will get 1.5 times TAB will be equal to TAC. Let this is your equation number 2. Now what we will do is that put equation 2 in equation number 1, which is this one. You can see. So I will write TAB plus, instead of TAC I will write 1.5 times TAB minus 2800 is equal to 0. So 2.5 times TAB will be equal to 2800. So TAB will be equal to 2800 divided by 2.5, which will give you 1120 pounds. So it means that your force in wire AB is equal to, if you divide it by 1000, so it will be 1.12 KSI. KSI means kilo pounds. So this is the force in wire AB. Okay. Now you have this value of TAB. Put value of TAB in equation number 2. So equation number 2 says that TAC is equal to 1.5 times TAB. So 1.5 multiplied by 1.12 KSI will give you TAC. And you will get TAC is equal to 1.68 kip. Sorry, the unit is kips, not KSI, because KSI is the unit of stress. So this will be kips. Kips mean kilo pound. So here we will also correct it. So these are the answer of our this question, where the force developed in wire AB is 1.12 kips and in wire AC is 1.68 kips. And that was all about this problem 4-38. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about every new video which I post. If you have any question, you can ask me in comment section. Thank you for watching and supporting. Welcome back. In this video, we are going to solve problem 4-39 that is taken from chapter number 4, Axial Load, and the book name is Mechanics of Material by R.C. Hibbeler. So statement is the load of 2800 pound is to be supported by two essentially vertical A36 wire if originally wire AB is 60-inch long and wire AC is 40-inch long. Determine the cross-sectional area of AB if load to be shared equally between both wires. Wire AC has cross-sectional area of 0.02 inch. So you can see this is load that is suspended from by two wires AC and AB that is made up of A36 steel, and the length of AB is 60 inch and length of AC is 40 inch. The cross-sectional area of 0.02 of AC, so you have to find the cross-sectional area of AB. So let's start with the given data. So we have been given that load of 200. So this load is W is equal to 2800 pounds and two A36 steel wires. Length of this wire AB is 60 inch and length of this wire AC is 40 inch. Cross-sectional area of AC is equal to 0.02 square inch, and it is given that load is to be shared equally. So load is to be shared equally. So what we have to find is determine the cross-sectional area of AB. So we have to find area of AB. So let's start with the solution. So first step is that we have been given that load is to be shared equally. So if this is your point A, clear, where there is a load in due to the load that is acting downward, and this load is W. Let me draw it. This load is W that is acting downward, clear, and this W is equal to 2800 pounds. So at this point we have wire AC. So force in wire AC is TAC, and similarly force in wire AB is TAB. Since it is given that load is shared equally, so TAB is equal to TAC, and that is equal to 2800 divided by 2. So from here you will get this TAB is equal to TAC is equal to 1400 pounds. Now you have this load, clear, in each wire. Since these both wires are of A36 steel, clear. So deformation will be same in both. Same, because the load is also same. So we have deformation of EB will be equal to deformation of AC. And we know that deformation is equal to load into length divided by cross-sectional area into E. So what we will do is that this will be equal to TAB into length AB divided by cross-sectional area of AB into E is equal to TAC into length AC divided by cross-sectional area of AC into E. Now we do not know E, but hey, we have been given that A36 steel wire. So you have to go at the end of the book, clear, and in book you have to go to the average mechanical properties and you have to look for A36 structural steel. So you can see this is 29 into 10 raised to power 3 ksi. So this is for US customary. If you have been given for millimeter or meter, so you have to go to the SI unit. But here we are following US customary because we have been given in inch. So 29 into 10 raised to power 3 ksi will be the value. Okay. So we will write for A36 steel, we have E is equal to 29 into 10 raised to power 3 KSI. Now put the value TAB is given calculated as 1400, length of AB is 60 inch. That was written in data. You can see this is the length AB, this is length AC. Each and every data is given. Cross-sectional area of AB is not known, into E, which is 29 into 10 raised to power 3 KSI. So we will multiply 10 raised to power 3 additionally to remove this kilo. Clear? And that is equal to 1400 multiplied by length of 40. Length is 40. Okay. Length is 40 for AC. You can see this length is 40. Okay. Divide by area of AC 0.02 and E is 29 into 10 raised to power 3 KSI, and KSI will be again 10 raised to power 3 because that will be in pounds. Okay. So now when you calculate this, this will cancel with this, clear, and this 1400 will cancel with this. So you will left with area of AB will be equal to 60 divided by 40. Multiply by this 0.02. You can see this will go toward this side. This 60 is there and 40 will be downward and 0.2 will be multiplied. So when you calculate it, you will get a cross-sectional area of wire AB comes out to be 0.03 square inch. And that is the answer of our this question 4-39. And that was all about this problem 4-39. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.